All right, guys, real quick video for you guys on velocity, acceleration, and position. Just remember, the original f of x, or whatever function they give you, is our position. Our derivative is our velocity at a given position. And then our acceleration is the second derivative at that given position with that specific velocity. So just remember that you derive this way and you integrate this way. So we can integrate all the way back to the initial position of something if we know enough information. So for today's worksheet, all you're worried about right now is for the first 4 or 5, you guys are just taking the derivatives. So remember, this is dy, I wouldn't say this is dy dx, and this is the second derivative of y with relation to x squared. So it just the values, so just remember it's based on the, can't even think right now. It's based on the variables that you use. It still doesn't matter. This is still a function. Instead of f of x, we call it s of t. And then so you would find the derivative of t, which is going to equal whatever it is, which is negative 16 t plus 3. And then you can take that derivative, which is going to give you negative 16. And now you have your position, velocity, acceleration. I always like on these just to actually grab those and figure out all three right at the beginning. So when you're given a position, you can just plug, when you're given a time, you can plug a time in for any of it. When you're given a height and they want to know the velocity, so if you're given a height of, let's say, 100, right? Well, you would take 100 and set it equal to the position, because height is a position. So height is a position statement. So if they give you the height of something, that's a position. So if we can find the height, then we can set that equal to t squared, or to the position statement, and then we can find t. And remember, on these, when you find t on something like this, you're going to get 2 of them. So you're going to be able to use 2 t's here. And then if they wanted the velocity at those specific t's, after we found the height, we would then plug the position answer, position of h at t, we plug that into s prime of t, and that would give us our velocity at each one. When it's a squared like this, your acceleration is always going to be whatever the constant is in front when you're done here. So again, this is for number 6. When you're given a height, you set it equal to the position statement. Remember, height and time are position statements. So if they give you the time, you can find what height it's at. If they give you the height, you can find out what time it's at. So that's how position statements work. And then from there, if we take the derivative, we're just finding the exact slope or the exact speed of that particular whatever rocket, particle, whatever it is at that point. So just remember, for position, velocity, acceleration, derive this way to find all 3. You can integrate going backwards towards the initial position. Anything that has to do with position, height, time, or whatever we're talking about, you can plug into the original position statement if they give it to you, and you can work from there. Other than that, guys, we will get going on position, velocity, and acceleration in the next couple of days. Good luck.